Hello and good afternoon, CSI158 Section 841 and 847 students for the spring 2014 semester at Anne Arundel Community College. Today's PacketTracer tutorial is going to be the Skills Integration Challenge from Chapter 10, PacketTracer Activity 10.3.1.2, and we've got quite a few tasks to accomplish here, so we're going to jump right in. As you can see, we have our addressing table here that's going to help us out with our sub-interfaces for our router on a stick configuration for router 1, in addition to the subnet masking information. And this information right here is really going to make it easy for us to come up with the IP addresses that we need for the DHCP configuration, as well as for the subnet masking that we configure on a number of the interfaces. All right. So first thing we want to do is create VLANs on switch 2 and assign VLANs to appropriate ports. And the key here is to remember that the names are case sensitive. So we'll jump on switch 2 and we're going to get into the CLI here. And we're going to go from user exec into privilege exec and then into global config mode. And so the first thing we're going to do is we're going to create the VLAN. So VLAN, and the first VLAN name is going to be sales. So VLAN 10. And the name is sales, and then we can do VLAN 20, and the name will be production, and then we'll do VLAN 30, and the name will be marketing, and then we'll do VLAN 40, and the name will be HR. And so let's take a look at our names to make sure we don't have any typos in there. Everything looks good. So we've created each of the 4 VLANs that are required, as you can see right here. Now it also shows us which ports need to be in which VLANs, and so we're going to get to that in a second. So let's go ahead and exit from this mode, from the VLAN subconfiguration mode, down into global config mode, and we're going to go ahead and make the port assignments right now. So if I do int range FA0/5 to 9, I'm going to go ahead and do switch port mode access, switch port access VLAN 10. Now I'm going to go ahead and turn on port fast, right? Because these are host-facing ports. And we're going to get a little warning message there, but we're okay. All right, so we've taken care of the first set, so let's exit from here. And we'll go back to global config mode. I'll do int range FA0/10 to 14. And we're going to do the same thing again. So we're going to do switch port mode access. We're going to make these access ports. We're going to make sure that they're assigned to VLAN 20, and I'm going to turn on port fast. And remember that port fast, within the context of spanning tree, and that's actually covered in the third of the 4 courses for the Cisco Networking Academy. So what we're doing when we do spanning tree port fast is that when you connect something to the port, it doesn't actually send out a topology change notification, BPDU, or a Bridge Protocol Data Unit. It actually skips the listening and learning. It goes right to the forwarding state, right? Okay, and so we're also going to go ahead and, where are we at here? So we're good there. And so I'm going to come back to the interface range, FA0/15 to 19. And we just did 10 to 14, so 15 to 19. And we're going to do the same thing. So switch port mode access, switch port access VLAN 30, VLAN 30, and spanning tree port fast. And then finally, we're going to go to interface range FA0/20 to 24, switch port mode access, switch port access VLAN 40, and spanning tree port fast. All right, so we've gone ahead and taken care of the VLAN creation on switch 2. We've assigned the VLANs to the appropriate ports, and we've made sure that the names are accurate. And so now the next step is to configure the switch 2 ports for trunking. So if you take a look here, I slid over, you can see FA0, 1, 2, 3, and 4 are going to be the trunk ports. Now, in the real world, you might do an ether channel here, right? And again, that's something that's not covered in this course, but it's where you take two physical links, which would be FA01 and FA02, and you create a single logical link, and that's known as ether channel. But here, all of these ports are individual ports, and so we're going to go int range FA0/1 to 4, and we're going to do switch port mode trunk. As you can see, the state has changed to up, and we'll make sure we do a no shut. We'll do that across the board actually, so I'll do int range FA0/1 to 24, and we'll do no shut, and all the ports should be up. Okay, so that's it for the FA01, 2, 3, and 4, and these are going to be trunk ports. In fact, if you were to click on switch 3 and do a show run, and do a show run, you would see that switch 3 has FA01, 02, 03, and 04 are also set up as trunk ports, and they've got port fast on their ports. So if you take a look at switch 1 here, oops, got to go to privilege exec, do the show run command, and you can see here switch port mode trunk, right? And they've got port fast on. So you can have port fast on those ports as well. So we'll go ahead and turn that on ours. Spanning tree, port fast. Okay. So let's go ahead and do a level set here. I'm going to write the memory out. I'm sorry, write the configuration out to memory, and then do a show run. So as you can see, 1, 2, 3, and 4, right? Those are trunk ports. We've got port fast on. 5, 6, 7, 8, 9, and 10 are in VLAN 10. Then 11 through 14 are VLAN 20. 15 through 19 are in VLAN 30. And then the remaining ports are in VLAN 40. So you can see we also have gigabit Ethernet 1.1. And so let's do int range GI 1/1 to 2 and make sure that these guys are up, and switch port mode access, and then spanning tree port fast. Even though those ports aren't being used, we're going to go ahead and bring them up to make sure we don't lose any points. And let me go ahead and do end. All right, so that was switch 2. Let's see our next step. We've configured the switch 2 ports for trunking, so configure all non-trunk ports on switch 2 to be access ports. So we did that on gig 01 and 0, or gig 11 and 12. All right, so it looks like for the switch configuration for the time being, we're going to be complete here. So I'm going to go ahead and close this out, and now we're going to be doing some work on router 1. All right, so let's take a look at router 1 here. So we want to configure router 1 to route between VLANs. So we're going to be doing a router on a stick, inter VLAN routing. So I'm going to go ahead and go from user exec into privilege exec, and then we're going to jump into interface gigabit Ethernet 00. So we're going to go to global config int gig 00, and then from here I'm going to do a no shut command. I'm going to bring that interface up, and that's going to have an impact on all sub interfaces that get created. So let's go int gigabit 0/0.10, right? So from here I'm going to assign the IP address, which is going to be IP address 172.31.10.1. And if you remember earlier, let me slide back up here. A lot of the legwork was done for us in terms of determining subnet masks and what IP addresses we would need to use. And so from looking at that, I already know that the subnet mask is going to be, 255, 255, 255, 224, which is a /27. All right, so I've assigned the IP address, but we can't do that, right? The first thing I need to do is set the encapsulation .1Q10 so that it's set up as a trunk, or I shouldn't say set up as a trunk, but set up so that it will recognize VLAN 10 traffic coming in, that it's going to be encapsulated as VLAN 10. Then I can apply the IP address. So the IP address is now set. So now if I go into interface gig 00.20, right? Same thing, encapsulation .1Q for VLAN 20. So that way any traffic tagged with VLAN 20 coming into gig 00 we'll use this sub interface to route the traffic. IP address 172.31.20.1, and we know from looking at our addressing table that it's 255.255.255.240. All right, and then int gi 0/0.30, and same thing, encapsulation .1q for VLAN 30. IP address 172.31.30.1, and the subnet mask is 255.255.255.128. And then finally, we're going to create a subinterface for VLAN 40 and encapsulation .1q 40, and then IP address 172.31.40.1, and this is a 255.255.255.192 or /26. All right, so we've got all of the VLANs, or the subinterfaces, configured properly for the VLANs on router 1. And so that's been set up. So now we need to configure some DHCP addressing information here. So it says configure router 1 to act as a DHCP server for the VLANs attached to switch 2. So create a DHCP pool for each VLAN. Names are case sensitive, and so here are the names for the DHCP pools. So it removes any uncertainty. DHCP pool, and the first one will be VLAN_10, and the next one's VLAN_20, VLAN_30, and VLAN_40. And so that's a really quick way. Now, if I were to do continue configuration work, maybe set the default router or the DNS server, that information is going to be done under the last pool I created, so VLAN 40. So what I'm going to do is I'm going to go IP DHCP pool VLAN_10, because I'll do them in order. So we'll do 10 first. So it says assign the appropriate addresses to each pool. And so the first thing we're going to do then is the network statement, and it's going to be 172.31.10.0. And we're going to use that same network statement, and then I'm going to use the subnet mask 255, 255, 255. And so a little higher up we've got it, but it's a /27. And if we remember, a /27 would be a 224, right? 224. And then just for a really quick review, looking at these different subnet masks, I'll go over to the board here so I can draw a little bit. So if I come up here, right, you remember, let's say the first 24 bits, right? So we'll say the first 24 bits are used. And that's the default for a class C, right? Default for a class C. And so you'd have 1, 2, 3, 4, 5, 6, 7, 8, period, 1, 2, 3, 4, 5, 6, 7, 8, period, 1, 2, 3, 4, 5, 6, 7, 8. Meaning the last 8 bits would be for hosts, 3, 4, 5, 6, 7, 8. So what we're saying, so when I say 24, this is where we're getting those 24 bits, right? So here are my 24 bits. So when I subnet, if I do a 27, that would mean, and let me change my color here, that would mean a /27 is that I'm going to borrow 3 of the host bits and turn those into network bits, and so that would then be a /27. /28, same thing. I'd borrow 1 more, and then we would call that a /28, right? /28. And so the way that you determine what the subnet mask notation is we know that all of these values here, when they're all on or they're all subnetted, it's 255, right? So you've got 255.255.255. So how do we determine that here? So again, we've got 8 bits, 2, 3, 4, 5, 6, 7, and 8. And the values are, and I'll write them up here, 128, and then 64, and then 32, 16, 8, 4, 2, and 1. And so the /27 says these 3 bits, right, equal, and it's 224. If it was a /28, I'd add in the 16, and that would be equal to 240. If it was just a /26, so just these 2 guys, it would equal 192, and a /25, which means it's just one bit position is borrowed, that would be 128. All right, so again, just a quick review as to how we come up with those values that we're using. And now let's go ahead and drop back into configuration mode here. So we're in DHCP Pool VLAN 10. We've declared the network statement, so that is the range of addresses that are going to be used. So we'll hit enter there. So it says provide the default router address. So we know that that's going to be the address that we configured on router 1 on the sub interface on Gigabit Ethernet 00. So it's going to be 172.31.10.1, and it wants us to use the DNS server address of 209.165.201.14. And let's see what else we've got here. And it says configure the DNS pool. So we got the pool name is case sensitive. Then it says prevent the first 10 addresses from each pool from being distributed to end devices. And so remember, that's our DHCP exclude. So IP DHCP exclude address. If I do the question mark, this is going to be the low address. So we know that it's going to be 172.31.10.1. But what is our high address going to be? And so let's jump back over to where we were doing some work here just a second ago. Whoops. Where we were doing some work just a second ago. And we're going to take a look at that right now. So we know that for a /27, right? And actually, let me go ahead and flip a page here. So for a /27, we've got 1, 2, 3, 4, 5, 6, 7, 8. So in the last octet, we've got these 8 bits. And we're assuming that the prior 24 bits, right, they're going to be to the left-hand side here. So I'll put a little dot there for you. So when we borrow the bits, and I say we're going to steal this guy for a network bit, we're going to steal this guy for a network bit, and we're going to steal this guy for a network bit, right? So that's going to be our .224, right? It's a /27. Now, we still have 5 bits left, 1, 2, 3, 4, 5. And if you remember, our notation, or our equation, I should say, for determining the number of host addresses is 2 to the x, x being the number of bits that remain for host addresses minus 2. And in fact, let me erase that real quick. And we'll get back to this guy here. So 2 to the 5 minus 2. So that's going to give us the number of usable addresses. So if you remember, in figuring out the IP, so 2 to the 1, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, and so we know that this is 32. Whoops, 32, pretty bad 2 there. 32 minus 2, so there are going to be 30 usable IPs, and so we would then be able to say that the subnet is going to be 172.31.10.0 all the way up to 31, to .31. And so that is our subnet, or our net ID, right? So this is going to be the network ID, and this is our broadcast address. So all the addresses that fall in between those guys, which would be .1 all the way up to whoops, held it down a little too long there, .30, these are our usable IP addresses right here. Okay? So keeping that in mind, we'll come back over here. So it's going to be from .1 all the way to 172.31.10.30. All right. And so that wraps up the DHCP pool for VLAN 10. Now let's go back in, IP DHCP pool, and we're going to create the pool for VLAN _20. And now that we're in here, again, we're going to go ahead and assign the appropriate addresses to each pool. So it's going to be the network statement, 172.31.20.0. And if we look over here, we can see that VLAN 20 is a /28. And so if a /27 is 224, a /28, which is one additional bit, would be a 240. So 255.255.255.240. All right, and we need the default router address, and we know that that is the sub interface on the router on a stick configuration on Gigabit Ethernet 0/0, 172.31.20.1, and we know the DNS server address is going to be 209.165.201.14. Okay, and then it says prevent the first 10 addresses. So let's go ahead and do IP DHCP-exclude address. And remember, we're going to do 172.31.20.1. And let's jump over here real quick for a quick workup of what we're doing here. So we'll flip the page, and we're taking a look here. This is going to be 172.31.20.0/28. Right, and so we need to know what are the usable host IPs here. So again, /28 would borrow 4 bits. So we'll do the dot again, assuming that the 24 bits, 24. Whoops, that is really bad. Let's erase this. So we're going to erase this out here. Let's try that again. All right, so we have 24 bits over here to the left. Right, and then we're going to say 1, 2, 3, 4 of those bits of the last octet are going to be borrowed, right? And so this is where we end up with our /28, right? And you've got 128 plus 64 is 192, plus 32 is 224, plus 16 is equal to 240. And so when we do our net mask, that is where we're getting that 240. Now, we need to know what 2 to the 4 minus 2 is equal to. Well, if 2 to the 5 is 32, 2 to the 4 is 16, minus 2 is 14. So there are going to be 14 usable host IPs, and they are going to be 172.31.20.1 all the way up to .14. Oops. Get my color to change there. And so again, so there's 14 usable IP addresses. So it's going to be .1. We would go from the network ID of .0, right, all the way up to .13. And that's our broadcast again, bcast. And this is our net ID, network ID. And this is going to stop at .12, right? And so then it would be, if you had many subnets here, we would go from 0 to 13, and then 14 up to 27, and then 28 up to, and you would just continue to add 13. So 41, is that right? Yep. And then, 42, and so forth and so on. And so your block size here, or your increment, it's going to go up by 14 every time. And so then this would be 56. And then if it went up again, it would be 60. And so then you would have multiple subnets if you were to create multiple subnets. So, but what we're interested in right there, the usable IPs, right? From .1 to .12. And that doesn't leave us a whole lot of usable space, because we've excluded, or we're going to exclude, those first 10 addresses. 20.12, right? Or I apologize, 20.10. So that's going to be the range of addresses that we're going to exclude. So we only have 2 IP addresses that we're going to be able to assign out of this pool. All right, so IP DHCP Pool, and this one's going to be called VLAN_30. And again, we're going to get a lot of work here on DHCP Pool creation, which is a great thing. So assign the appropriate addresses to each pool. So network is 172.31.30.0, and this is /25. So 255, 255, 255. So /24 would be 0. 25 borrows that next bit, which is valued at 128. All right, so we've got that in there. So the default router will be the same address that's on router 1 for this subinterface, 172.31.30.1. And the DNS server is going to be the 209.165.201.14. Let me make sure, 209.165.201.14. Okay. And we've got the gateway address in there. And so now we need to go ahead and exclude IP DHCP exclude the range of addresses we don't want used, which are going to be 172.31.30.1 up to 172.31.30.10. And that blocks out the first 10 addresses from being used. All right, and then last but not least, DHCP pool, it's going to be VLAN underscore 40. And we're going to go ahead and create the network statement, which is going to be 172.31.40.0. And then this is a /26, so it's going to be a 192. 255.255.255.192. With the default router, again, 172.31.40.1, because that is the subinterface on router 1. And then we're going to go ahead and do the DNS server of 209.165.201.14. And we've got to go ahead and do the IP DHCP exclude address, and we want to exclude 172.31.40.1 up to 172.31.40.10. Okay, and so we've excluded those addresses out. So we've done a lot of work here, so let's save that work to make sure nothing bad happens. So we've written that information out to memory, right? We've saved the config to memory. So we've got the routes all set up between VLANs. The interface names are there. All of the DHCP information should be good. We've assigned appropriate addresses to each pool. We've configured DHCP to provide the gateway address as well as the DNS server, and we have our exclude statements in there. So verify that each PC has an address from the pool. So if I were to do a show IP DHCP binding, as you can see right now, nobody has an address, and that's to be expected because we need to do some work here on these guys. So everything looks good right now. You can see we're 70 out of 100, so we're making great progress. So we'll come over to PC1. We're going to go to the desktop. You'll notice that they're static by default, so now I'm going to flip it over to DHCP, and in a couple seconds here, I should see .11, and you can see here it says DHCP request failed, so we may have some troubleshooting to do. Let's check PC2 on VLAN 20. Let's flip it to DHCP. See if anything works. All right, so VLAN 10 did not work, but VLAN 20 is working. You can see right here that we've got our address, and it's that first available address. Let's see if VLAN 30 is functioning. Whoops. Pull back PC3 to the desktop, and we're going to go DHCP, and let's see what happens. All right, VLAN 30 is working, and I may have typoed an IP address somewhere on VLAN 10's configuration, and 40 is working. Okay, so it looks like 20, 30, and 40 are good. PC1, let's check it again, make sure. We'll flip it to static, flip it back to DHCP, make sure it's not an anomaly. All right, the request failed. So we've got a failure somewhere here. So let's start at the first place that we should take a look. Let me do a show IP DHCP binding. As you can see, we can see now that VLAN 20, 30, and 40, we've successfully had addresses assigned. And these are the network interface cards, the NICs. This is the MAC address for the NIC on PC 2, 3, and 4 respectively. But we've got some issues with VLAN 10, so let's take a look. So we excluded from 10.1 to 10.30, right? So we definitely have a typo here. So this is definitely a mistake, and it looks like what I did was I actually put the entire range of addresses in there. I don't know if anybody caught that when I did it, right? So let's go ahead and do configuration, and we're going to do a no IP DHCP exclude, and then I'm going to go ahead and fix it. We'll put from 10.1 to 10.10. All right, so that's fixed. So now let me go ahead and save my config. And let's do a show IP DHCP binding. So we don't have anything from VLAN 10 yet, but let's pull that PC up. Let's see what we've got. We'll flip it to static and then back to DHCP, and let's see if it works. Requesting address still failed. So it looks like there may be another problem out there. So let's do a show run again. So the exclude statements are correct. What about the pool? Does the pool look good? Network 172.31.10, and the subnet is correct. The default router 172.31.10.1 is correct. So that looks good. Let's take a look at the interfaces. Let's make sure our sub interfaces were properly configured. 172.31.10.1. So that looks good. All right, the interfaces look good. They're all up. Default route is out gig 01. So let's do that show IP DHCP binding again. We've got nothing. So let's close this guy down. We'll come back to PC10. Let's make sure it's not an anomaly. Sometimes in PacketTracer, when you come back and forth between the GUIs, it will not work. All right, so it's not working. So let's continue to troubleshoot this. So let's check switch 2 to make sure that switch 2. So let's take a look at switch 2. We haven't looked at that, so we'll go from user exec to privilege exec. And let's do a show run here. And so port 5, so PC1 is in VLAN 10, switch port access VLAN 10, switch port mode access. It looks good. All right, so we're in the right VLAN. So that's correct. Let's make sure that our subnet information is correct. Make sure I didn't look past something. So show IP interface is brief. And let's make sure we've got 10.1, 2030.1, so that looks good. Let's come back over here. 225.224, 72, 31.10.0, IP DHCP Pool VLAN 10. So that is correct. All right, it actually looks decent. So let's do this. Let me go ahead and configure the gig 01 interface, the next step, and we're going to come back and take a look at this. So we're going to do global config mode, and we're going to go into int gig, and what are we doing? Gigabit Ethernet 0/1. We'll do no shut, and then we're going to bring up IP address DHCP, and it's going to get its DHCP IP address from the ISP. And so we've got that completed. Okay, so let me do an end, right mem. And so we're good there. So we're 93 out of 100. Let's check our results. Let's see what it says. Maybe it's going to give us a hint as to what might be wrong. So as you can see, PC1 here, it's not getting any of this information. So we've got the red X's. So we're green all the way down just about, right? And this is going to go green here in about 10 to 15 seconds when gig 01 does get its information. So we'll roll back up, we'll click close, and let's pull up this here, and we'll do show IP interface brief. Remember, the interface isn't going to show it with the show run. We're going to have to wait for the DHCP address to be assigned. So this should take a couple more seconds and we should be good to go. And there it is. All right. Okay, so gig 01 has received its IP address, and now we're 96 out of 100, but we're still not happy over here on PC1 on VLAN 10. And so let me go ahead and do static. Let's make sure that nothing's changed here. It's still going to fail out on us. And it does. So let's come over here, see if it sees anything. So it doesn't see anything, so we'll do an ipconfig-all. No, ipconfig/renew, which is what we were doing in the GUI window, and now I'm coming to the command line window to see if we can get some help here. So no help at all, so failed again. So one more time, let's walk through each of these configurations here. So FA05 should be in VLAN 10. So if I do a show run, interface fast Ethernet 05, switch port access VLAN 10, switch port mode access, spanning tree port fast, and the port is up. Right, so we'll do a right mem. Can I ping? Let me see if I can ping. Oh, I don't think I have the default gateway configured, so we're going to let that go. So we should be able to get through 2 gig 00, and everything looks good here. So let me do this. IP DHCP Pool VLAN 10 172.31.10.0. That's correct. 172.31.10.1, and the DNS server is correct as well for the pool. The excluded addresses, it's excluding out, aha. Nope. All right, still in error here. 10.1 to 10.10, and it should definitely have enough addresses. Let's take a look again. Let's make sure that the sub interface is correct. 172.31.10.1, that is correct. The 224 is correct. And I know that we should be able to get 100 out of this because I've actually completed this packet tracer in class. So let's see if we can ping out from this guy here to the 209.165.201.14. See if we can ping out to the DNS server from PC2, and we're not having any luck. And now I'm going to try to ping the Cisco.pka web server here next. Let's try that. 209.165.201.10. 209.165.201.10. So from PC2, can I ping out? And it doesn't look like we're having any success. Oh, there we go. So PC2 is working. All right, good. So from PC3, can I ping out? Let's go ahead. IP conf. Whoops. Close that down. Try to ping 209.165.201.14. We should get a couple failures as it ARPs out, and then we should get some success. And there we go. So that PC is working. What about PC4? Ping 209.165.201.10. And the first request times out, and then it succeeds. All right, so we are still 96 out of 100. So I'm going to try something here. Let's drop a static on here, 172.31.10.11, or actually 10.12. We'll do 255.224, and the default gateway would be 172.31.10.1, and the DNS is going to be 209.165.201.14, and let's see if this will allow us to ping out. So now let me try to ping. Whoops. So the command prompt's not responding. And I'm wondering if this could be a bug in PacketTracer. Alright, so now I've got that information in there. Let me flip it over to DHCP and see what happens. Requesting address. So the DHCP continues to fail on PC1 for some reason. Alright. It won't take a static. Let's see. Yeah, and it looks like the command prompt is locked up here. So this could be a bug. In fact, we've actually lost. We had a point. We had 96. Now we're down to 95. So let's see from our assessment. Yeah, right. The default gateway DNS DHCP client enable. So I'd click off DHCP client enable, and it took a point away. So PC1 is clearly causing us some problems, but we're good with everything else. So let's go ahead and close this down. Make one last attempt here on PC1. Requesting the IP. Fails out. We're in the right VLAN here. We're in VLAN 10. We shouldn't have any problems there. We've got the right information configured here. Let's double check this one more time. So we're excluding 172.31.10.1, 172.31.10.10, and there's our pool, 31.10.0, 255, 255, 255, 224. We've got our default router address in there, which is correct, 172.31.10.1, and the DNS server is also correct. So let's take a look. at our interface. And there is our interface, encapsulation .1Q10, 172.31.10.1, and 255.255.224. Alright, so this appears to be possibly a bug that we've encountered, although, as I said, I've completed this before in class. So it could be that just the way we were doing it is forced something to happen. The trunk links, we should be fine there. All the other PCs can ping out. I simply don't get a DHCP address on VLAN 10, which is interesting. So it won't take a static. The DHCP fails. And okay, so we've got this back. So let me try that with the static again. See if we can force it. 172.31.10, and I'll go ahead and put 11 in here. 224, and 172.31.10.1, and the DNS server is going to be 209.165.201.14. And so let's see. Hopefully we can get this. Yeah, as soon as I put the static in there, it won't take it. Let me see if I can ping from this guy, from PC2, ping 172.31.10.11. So let's see if we can ping that PC that we just assigned the static IP to. Alright, so we can ping that PC. Now if I flip it to DHCP, does that help him at all? Yeah, the DHCP failed. But the DHCP should function. The configuration is identical for all of the VLANs. 10.1. And the exclude statements are correct. Okay. Alright, so we're going to let this one go, as simply we've encountered some sort of a bug, which is not unheard of, in PacketTracer. Alright, so this has been the Skills Integration Challenge for Chapter 10, 10.3.1.2. Alright, I hope this was useful, and I will see you all this week.